Hello everyone, for this presentation we have four main topics. First one is what is matrix, second one is what is the matrix dimensions and how to find it. Third one is why do we need matrices in all our systems or our design. Fourth one is how we are going to use matrices in our concepts in linear algebra. So let's start from the first one. The matrix is this. Matrix is shown in this way, in a square bracket. And actually this answers our first question. The second one is, what is the matrix dimension? Usually, to find matrix dimension, we are looking at the right bottom of this square bracket. And this sometimes can be m times n, which stands for m row and n column. So we have to define what is the row and what is the column is. The row is, this is it, the first row, the second row, the third row, the fourth one, the fifth one. And what is the column is the first column, the second column, the third column, the fourth column, and so on. To be concrete, for example, we have a matrix, right? And I say there's a 2 by 3 matrix. The dimension is 2 by 3. And how many rows in this matrix? Certainly it is 2, 1, and 2. How many column in this matrix? Including 1, 2, and 3, because this gives the column part and this gives the row part. Okay, I think we are very clear about that. And why do we need matrices? The thing is that we are using matrices to store data, to store information. What kind of information is the question we should ask ourselves? Storing data, to be sure I am going to write it. Data, information. And I ask to you what kind of information we are going to store it. This can be a number, this can be a string depending on the context. But in linear algebra, in math, we are going to store the numbers in these matrices, in these dimension matrices. Okay, we are going to store the numbers in linear algebra. Okay, how we are going to use matrices in linear algebra? The thing is that we usually make an experiment and we are resulting in some equation. This equation can be sometimes simple. There could be a two equation with two unknowns, such as this. This is the first equation. This is the second equation. You know how to solve it. You are multiplying this with -2 and then add them up together. It's two equations. Right, and result in -3, so that these 2x's and -2x's go away and there's a -y equivalent to 1, then y equivalent to -1, right? And then you are putting y equivalent to -1 in the one of the equation. Then I am going to put the second one. Let me give a star in here, and x -1 equivalent to 1, then x equivalent to 2. We find it pretty clearly. But what if we have 10 equation with 10 unknown? Or 100 equation with 100 unknown? And apparently we are not going to find a quick way to realize that how we are going to multiply with the which equations. And this is quite time consuming, and so that to get rid of this time consuming stuff, we introduce and we are going to use matrices effectively. And in the next presentation we are looking at the basic operation with matrices, and at that moment that will make sense in your mind, and I am going to refer this issue with more complicated equation. See you in the next presentation.